Now let's use dimensional analysis to carry out unit conversions. All right, so you've got a number, and you want to know what that same value is in a different set of units. So there's this pretty straightforward way to go about doing these calculations. We want to go from one set of units to another, and I'm going to just write it out in a sort of general formula. Okay, so let's say you have a number, and we use a box just to show that this can be any number. It's not a specific number, it's just some number that you have. And the units of this number are in your old units. Old units. Not unity. Units. Okay, you want to somehow get to a different number that's equivalent, but in a set of new units. So a new number that's in new units. All right. The way to go about this is to use dimensional analysis and the known fact that units cancel just like algebraic variables. So what we want to do is we want to multiply by a number that has new units in the numerator and old units in the denominator. So you've got basically a ratio of two numbers, or you've got one overall number that makes up this ratio that has new units in the numerator and old units in the denominator. And because we understand dimensional analysis, we know that old units will cancel out with old units, and the final answer will be left in the new units that we're interested in. All right. And what we do is we generally call this ratio that's in the middle that allows us to carry out our unit conversion a conversion factor. Conversion factor. And the real question is, where do these conversion factors come from? All right. Well, you might imagine you're hiking in the Alps and you're going to climb a mountain. You want to know how tall that mountain is. And one person measures the height of that mountain, and it's 1 kilometer tall. Okay. Another person measures the height of that mountain, and they say it's 1,000 meters tall, right? We know that 1,000 meters is equal to 1 kilometer because we've already talked about metric units. But here we have an example of where two different units are measuring the same thing. They have the same value, but in different units, okay? And usually when we write something like this, we can write it out like this. 1 kilometer is the same thing, or it's equals to 1,000 meters. All right, so we see these types of relationships between units all the time. You might say that 1 hour equals 60 minutes, or we might say that 1 pound or 1 kilogram is equal to 2.2 pounds. You know, we have examples of these all over the place, and we can always write them out as an equivalence. 1 kilometer is the same thing as 1,000 meters. Sorry, that's kind of a weird M. All right, so this is where our conversion factors come from. Another way of saying 1 kilometer is the same thing as 1,000 meters is you could say there's 1,000 meters per kilometer. And using this language, we can say there's also 1,000 meters per kilometer, or there's 1,000 meters per kilometer. All right, so an expression in this form can also be expressed in the form of a ratio of those two numbers. Okay, we could say there's 1,000 meters per kilometer. We can say that there's 1 kilometer per 1,000 meters, but we can always rewrite this equivalence in the form of a fraction, which we call conversion factor. Now, the key to carrying out unit conversions is to make sure that you create your conversion factor from this equivalence such that the new units are in the numerator, and the old units are going to cancel out to leave you with the new units. So let's say I've got a mountain and it's 5 kilometers tall, and I want to figure out what that's equal to, or what that value is equal to in units of meters. All right, well, I start with this relationship, and I create my conversion factor, and I'm going to create my conversion factor so that kilometers cancels out with kilometers. So I want to keep kilometers in the denominator. So what I'm going to write is there's 1,000 meters for every 1 kilometer. I know kilometers cancels out with kilometers. I know 5 times 1,000 is 5,000. So I know that that mountain is 5,000 meters tall. All right. That's using dimensional analysis to do unit conversions. You really want to stick to this general form. And you can usually, if you're given a relationship like this, you can always create a conversion factor. And you know which number to put in the numerator and which number to put in the denominator by how the units will cancel.